Here's your integrated 3 lecture for 12.1.4. We're going to learn the reciprocal trig functions. So each of the trig functions, sine, cosine, and tangent, have reciprocals. And so we did inverses last time, but that's different. A reciprocal is, for instance, we'll start out with sine. So the reciprocal of sine is called cosecant, and I'll show you how to graph cosecant. So what you can do is, since cosecant is 1 over sine, you can get some values for sine. Like when I plug in 0, I actually wrote this. This is a sine graph. When the angle measures 0, the sine is 0. And you can use a unit circle to get these if you want to. Remember, sine is the height. It's the y value. When the angle is pi over 2, which is here, sine is going to be 1. When the angle is pi, sine will be 0. When the angle is 3 pi over 2. So you just get these by either looking them up on the unit circle, or you can graph on Desmos, and you get sine. And then, so what would cosecant be? Cosecant would be 1. Well, if this is sine, then cosecant is 1 over sine, because they're reciprocals of each other. So what's 1 over 0? Because I want cosecant. Cosecant is 1 over 0. 1 over 0, that is undefined. So when the angle measure is 0, cosecant is 1 over 0. So I have to draw this dotted line like it's you can't, like we're going to restrict the domain right there. Okay, and that's an asymptote. So what would be cosecant of pi over 2? Well, it's going to be 1 over sine. So what's 1 over 1? 1 over 1 is 1. So we're going to have a point right here. Cosecant is going to have a point right here. What is cosecant when the angle is pi? Well, it's going to be 1 over sine. Well, 1 over 0 is undefined again. So I get this. So I hope you can understand that I'm getting this pattern. I get a -1 here. And these are asymptotes, and so I know the graph of cosecant, it ends up just looking like this, these U shapes. And it goes like this. And it always has a point at the 1s and the -1s, and it has asymptotes wherever sine is 0. So there would be an asymptote here. Wherever the sine graph goes through and hits the x-axis, that's where the reciprocal of sine, which is cosecant, is going to have an asymptote. And then we're always going to have these U shapes. So I hope that's a good enough explanation. This is the graph. So this graph is just sine. I just used it to help me actually draw the graph of cosecant. The graph of cosecant is just the U shapes, and it's got these asymptotes. I'm going to do the same thing for cosine a little faster. 1 over cosine, that's called secant. Okay, and so how would I graph it? The fastest way to graph it is to just graph cosine. I know cosine goes, if this is 1, well, here, let's get, here's pi, here's 2 pi, and we know there's places in between. Here's a -pi. I know that cosine goes through here, and then it ends up here. What's cosine? Let's find out what cosine of pi is. Cosine of pi is -1. Kind of assuming that you're a little bit familiar with the graph of cosine. Okay, so I graphed cosine. I know I'm trying to graph secant, but I'm using the graph of cosine to help me figure out how to graph secant. So now I see wherever cosine goes through the x-axis, I'm going to draw these asymptotes. Why am I drawing asymptotes whenever cosine goes through the x-axis? Well, that's because that's where cosine equals 0, and 1 over 0 is undefined. You can't divide by 0. So, and then I know these points right here, this is where I can make my little U-shapes. Because the reciprocal of 1 is 1. Because remember, we're talking about reciprocal functions here. And it would just go on forever and ever. So they're just U-shapes. Okay, that's for the reciprocal of sine, which is cosecant, and the reciprocal of secant, which is, or the reciprocal of cosine, which is secant. Now, there's also a reciprocal of tangent. I'm going to do that one real quick. So regular old tangent, and I think I don't want to run us out of time. I'll remind you what tangent looks like, so you might not remember. Tangent goes like this. Okay, so, and it keeps going. And interestingly, the period of tangent, this is y equals tangent. So y. Interestingly, the period of tangent is only pi, where the period of sine and cosine is 2 pi. So that's tangent, and I think that what I'm going to do at this point, since I'm running out of time, is I'm just going to show you how to, I'm going to show you what cotangent looks like, and then I'm going to ask you if you can figure out cotangent. I can say cotangent is equal to 1 over tangent, and maybe you guys can figure this out, but I'm just going to show you how the graph looks. It looks just like a tangent graph. Well, kind of like a tangent graph. Oh, I should have put some. This is pi over 2. This is negative pi over 2. This would be 3 pi over 2. This is pi. This is pi over 2. And cotangent is going to go this way. Okay, and I'm going to leave you to try to figure out why. So basically, if I took the time to make a table of the values of tangent, and then if I just flipped each one of them, you know, got the reciprocal of them, then I would plot them here and get cotangent. And so you'll notice, you can notice right away, this is supposed to be my y-axis and my x-axis. Sorry, y-axis. You can at least make some observations here. You can observe that tangent, when it goes through the x-axis, that's where tangent is 0. So 1 over tangent would be 1 over 0. So that's why we have to have an asymptote there. And we have to have an asymptote here. This is pi. See? And then this ends up going backwards. And I'll let you, maybe you can plot some points and think about that. But this is what cotangent looks like. Okay, and here's your graphs of cosecant and secant. I'm going to do a part 2 to show you how to do a little bit of algebra with this stuff.